Here is the test video, the final test for the air quality monitoring system and alarm. I'll also be undergoing a evaluation in this video as well. So as you can see, we have just simply hooked up the unit to a 3-pin plug via USB cable. This is for charging. Also, as you can see, the green LED is on, indicating that the air quality right now is currently safe. So let's test out the test switch functionality. So when I press this, as you can see, the siren went off and the lights came on. And yeah, the stakeholder said that these were sufficient in decibels and in lumens for the students and pupils in the area to be alerted. So, yeah. In terms of evaluation, well, firstly, I'd like to point out the strengths. So it does everything that we wanted it to do on the specification. It alerts the users. It also tracks the activity level in the area and stores it on the Arduino cloud. And yeah, we've introduced some visual aesthetic approach which allows anyone to understand what the alarm means if anyone were to come into contact with it by the obvious internationally recognized sign. So now let's undergo the evaluation. So firstly, I'd like to point out that in its upright position, it's waterproof, right? It's quite waterproof. However, I do want to note that there is a small gap here in between the sign and the plate. So if it's not in its upright position, this is not waterproof, so that's one thing to consider. I'd probably next time use some sort of O-ring or gasket around here to make sure that it's fully waterproof. The next thing I'd like to point out is if we take off the cover, which is actually mounted by these things which go underneath this lip right here. But we take off this is normally situated here and it's screwed in and nuts and bolted, but for the sake of demonstration I've undone these. Right, so now moving on to this. So another thing I'd like to point out is that instead of Velcro next time, I would probably 3D print some mounts. And now I know this is not upcycling materials and that 3D printing is using more materials, but actually a recent study has showcased that 3D filament can actually be melted and re-spooled into new filament which can be reused again, which definitely does go in line with the upcycling aspect of this project. So yeah, next time I would look into that. Also, next time I would like to actually get an external sort of breadboard or another proto shield for this, because as you can see there's quite a lot of wiring right now and that's only been connected via these terminal blocks and a bit of Vero board actually. So whilst this is a viable solution for now, I think in the future by manufacturing a PCB in the CNC machine in the DT lab, that will definitely increase the longevity of the product. yeah. Also, another strength actually is that the magnets on the back can actually withstand the weight of the entire unit. The entire unit is only 1.9 kg actually, which is just below our requirement of under 2 kg, which is just right, but this is going to the limits. So next time I'd probably, because this is a mild steel vent actually, so this contributes to quite a lot of the weight. But stainless steel vents can also be purchased in the same sort of design format and specifications, and so that can just be a one-in-one fix. It can be sort of like immediately substituted out for the lighter version, which would definitely minus about a kg from the entire design. So that's my evaluation. The stakeholder has sent me an email regarding the evaluation, which should also be on this slide. But yeah, thanks for watching.